In this session, we're going to look at set intersection, the word and. The word and is a conjunction, and what that means is if I say a sentence like this, you and I have to go to the office. What does that mean? That means that both of us have to go to the office at the same time. If we let this circle represent set A, and this circle over here represent set B, then the part where they overlap each other is the intersection of the two sets, A intersect B. And if you think about where two roads overlap each other, they overlap each other at the intersection. And so that's what we're looking for when we have a set intersection. If we let the set A have elements 1, 3, 5, 9, and 10 in it, and let set B have elements -1, 1, 2, 3, 4, and 5, A intersect B, we're going to have the set with the element 1, because 1 occurs in both sets. The next element would be 3, because 3 appears in both sets. And then the next element would be 5. 5 also appears in both sets. So A intersect B is what the two sets have in common. They have the numbers 1, 3, and 5 in common. Suppose we have inequalities. X is greater than 4 and X is greater than or equal to 9. Then we look at the sets on the number line. This is the number line. Here's the number 4 on the number line. And we indicate the boundary with a strict inequality, an open circle, or a parenthesis. And the number is greater than 4. Well, that's a number like 5, 6, 7, etc. off to the right-hand side of 4. Here's the number 9 on the number line. And we mark the boundary with a closed circle this time because of the inclusive inequality. And which way do we shade? We shade the numbers greater than 9, which is a number like 10, 11, 12, etc. Well, that's off to the right-hand side of 9. So now we're looking at the intersection of these two sets, and the two sets overlap everywhere from 9 on down. The intersection of x is greater than 4 and x is greater than or equal to 9 would form the set from 9 to infinity. Well, let's take a look at another example. If we have an inequality like 2x minus 1 is greater than 4 and 3x plus 5 is less than 10, then we're going to solve each of these and add 1 to both sides. We get 2x is greater than 5, and now we're going to divide both sides by 2, and we have x is greater than 5 halves. There's my first set. Now I'm going to work out the second inequality. Let's subtract 5 from both sides, and I get 3x is less than 5. And now I'm going to divide both sides by 3, and I get x is less than 5/3. Okay, so we want to graph each inequality, and we have a little challenge in comparing 5 halves and 5/3. Which one is bigger, 5 halves or 5/3? 5 halves is greater than 5/3. So when we make our number line, I'm going to mark 5/3 right here, and then 5 halves will be over here somewhere. Now the numbers less than 5/3, well, we indicate the strict inequality again with an open circle, and less than 5/3 would be on the left-hand side of 5/3, and then greater than 5 halves, open circle, and greater than 5 halves is off to the right-hand side. Now here we have a little mini dilemma. Do these two sets overlap each other? And the answer is no. So the intersection is empty. And we can indicate the empty set with this symbol like this, or a set with nothing in it.